Welcome to Lecture 7, 2.1, Organizing Qualitative Data. First objective is to organize qualitative data in tables. So by definition, a frequency distribution lists each category of data in the number of occurrences for each category of data. Okay, so first example, fill out the frequency distribution chart using the following qualitative data. So we have some data here. And what we want to do first is we're going to go ahead and tally each time we see one. So let's go ahead. First, we'll start out with back. So here's back, back, back. All right, so we see back how many times? 5 times. 1, 2, 3, 4, 5. And frequency, 5 times. You don't necessarily need to do the tally, but we're going to do that for fun. All right, next one is hand. So hand. Looks like it only shows up 3 times. Okay, let's do the next one. Elbow. So 1, 2, 3, 4. Okay, so elbow shows up 4 times. Oh, I do not know why I did that many random slash marks. 1, 2, 3. Okay. And then shoulder. Let's see. Let's do blue. Shoulder. Oops. Shoulder, shoulder, and shoulder. And we have 3 of those. And what we're missing is actually the neck. So I'll go ahead and fill that one in here. How many times do we see neck? 1, 2, 3. Alright, so we went ahead and we filled in just the frequency, so the number of times it shows up. Now what we're going to look at is something that's similar to frequency, but this is called the relative frequency. And it is the proportion or percent of observations within a category and is found using this formula. So the relative frequency is if you take the frequency and you divide it by the sum of all the frequencies. Alright, so let's take a look at example 2. Construct a relative frequency distribution using the data from example 1. So, once again, in example 1, we had to add on our little extra box piece here with neck. So, what was the frequency we saw for back? We saw 5. Then we saw 3 for hand, 4 for elbow, 3 for shoulder, and 3 for neck. So let's find the total. Okay, so adding these all up, let's see, we have 5 and 4, which would be 9, plus 3 would be 12, 15, 18. Okay, so this is going to be the sum of all the frequencies right there, is 18. So what we're going to do to find the relative frequency is you take each frequency, so for example for back we'll take 5, and you divide it by the sum of all the frequencies. And what do we get here? So 5 divided by 18 is going to be approximately 0.277. Let's see, and in our book it looks like they normally go to the 4 decimal places over. So let's go ahead and do that. 1, 2, 3, one more. 7. And I use the approximation symbol. So for hand, we'll do 3 divided by 18. Elbow, 4 divided by 18. Shoulder, 3 divided by 18, and so on. Go ahead and pause the video, try this out by yourself, and check back in with me in a second. Okay, so hand is 3 divided by 18. Approximately 0.1666. 4 divided by 18. Approximately 0.2222. And then the other ones are all 3 divided by 18, which you've already found. And the sum of the relative frequencies should always come out to be about 1. Since we rounded these all off, it actually comes out, when I add these all up, I get about 0.9997, which is about 1. But the sum of all the frequencies should normally end up being 1. But we were rounding, so it is a little off. Alright, let's take a look at Objective 2, constructing bar graphs. A bar graph is constructed by labeling each category of data either on horizontal or vertical axis, and the frequency or relative frequency of the category on either axis. Rectangles of equal width are drawn for each category. The height of each rectangle represents the category's frequency, or the relative frequency. Okay, so note there's frequency and relative frequency. Frequency is just when you count up the exact values. Relative frequency, again, is when you take the number of values you counted and divide it by the total of the frequencies that you found. Okay, so example 3. Use the data collected from example 1 to create a bar graph for both the relative frequency and the frequency. So let's go ahead and first create one using the frequency, because this was from example 1. So the frequencies we saw were back was 5. Okay, so back was 5. So this was the frequency. And let's see what's next. Hand was 3. Elbow was 4. Shoulder was 3. And neck was 3. Okay, so we're going to go ahead and graph this for the frequency. And let's label our, so this is the x-axis and this is the y. Let's label our y so it can fit these numbers in. It only goes up to 5. I'll just go ahead and label these by ones. So 1, 2, 3, 4, 5. For an actual exam, you'd be given out a graph most of the time. Sometimes you might be asked to estimate yourself with your own graph values, but if you're required to be exact, you'd be given a graph. Okay, and now what we're going to do is go ahead and label these. I'll just use B for back. So B for back, H for hand, E for elbow, S for shoulder, and N for neck. Actually, you know what? I'll make these a little farther apart. H, E, S, N. And let's go ahead and create the bars. So back should go up to 5. Here we go, my bar, all the way up to 5. And I could fill that in for fun. Then we have hand, which goes up to 3. And E, 4 for elbow. That's a little higher than 4. Okay, so the bars should be approximately the same width. This is all just a visual representation of the differences between the data that we found. So now looking at this, you can see that the times that, and let's just say this was a doctor who was collecting all this information, maybe on the patients that came in or something. So we can see that the head, shoulder, and neck injuries were about the same. The one we saw the most was back injuries. Okay, so that's why a visual graph would be helpful. Now let's take a look at the relative frequency. So for the relative frequency, I'm just going to go ahead and use the abbreviation for B for back, H for hand, E for elbow, S for shoulder, and N for neck. We had 5, 3, 4, 3, 3, and then the relative frequencies. Actually, let me go ahead and back that up. Those are not supposed to be that. Relative frequencies are about 0.2777, 0.1666, 0.2222, 0.1666, and 0.1666. Alright, so now we're doing relative frequency. I'll go ahead and label once again. B-H-E-S-N. But now we're labeling it using this data. So let's see. None of these even go up to 1. The closest we might get to would be maybe 0.30. It would be the highest value I could think of. Let's go ahead and go in 5s, 0.05s. So we have 0.05, and then after that we have 0.10, and then 0.15, and 0.20, 0.25, and 0.30. Okay, the way I decided to figure that out was I looked for the smallest number possible, which was just 0. Or almost looked like 0.16, and the largest number possible, which was almost 0.30. And then I thought, what are good steps to go by? And a lot of the time going by 5s is useful. Sometimes going by 2s is also useful. Okay, let's go ahead and create our graph. B goes almost up to 0.30, but not quite there. That line was not quite as neat as I wanted it. Okay. H goes almost to 20, but not quite at 20. E goes a little past 20, but not quite 25. S is the same as H, and N is the same as S. And since these are all approximates, you could go ahead and label them. And let's fill these in with some color. Why not? Color makes the world more beautiful. And lovely yellow. Putting on some pretty red. Finally ending with the so-called black, which looks more like a gray. Alrighty. That may not have won an art contest, but it looks better. Okay. Next. Alright. So, looking at a new definition, a Pareto chart, which I believe is the way to say it, I might be saying that wrong. A Pareto chart is a bar graph whose bars are drawn in decreasing order of frequency or relative frequency. Okay, so what we want to do is graph the data of relative frequency from example 2 in a Pareto chart. Okay, so the relative frequency, we had back was 0.2777, hand was 0.1666, elbow 2222, and then shoulder and neck. Okay, decreasing order. So the biggest one we see first is going to be back. After that, the next one is elbow. And then finally, the head, shoulder, and neck are all about the same. We can go ahead and use the same tick markings as previously, so the 0.5s. You could go ahead and pause the video and try graph this yourself and check back in with me. Okay, so let's see. B goes almost up to 30. E is almost up to 25. And then a little higher than 15. Alright, and there we go. It is in descending order. And once again, I'll go ahead and color these in for fun. Gotta make the video a little more colorful sometimes, huh? And lastly, once again, the black, but not quite black. More of a gray. Example 5. Construct a bar graph to compare the two sets of data. Okay, so we're moving on. Instead of just looking at one set of data, which we've been doing, now we're looking at two different sets of data. On the side, we have educational attainment, high school diploma, some college no degree, associate's degree, and bachelor's degree. And we're comparing the year 1990 and 2013. I was not around in 1990. Oh dear. Okay, so construct a bar graph to compare the two sets of data. Well, when we're constructing a bar graph that's comparing, you're going to be graphing the data for one of the graphs in one color, most of the time is how you do it, and then you graph the other data in another color. So what I'm going to do is, to set this up, let's go ahead and say 1990. We'll make this blue. You don't always graph it in different colors, but pretty much they do that to differentiate. And oops, one more back. Let me erase that. 1990 and 2013. Let's go with green. Okay, so we're given this data, and let's see. I want to graph these numbers. So I'm going to look for the highest number. The largest number I see is almost looking like 0.25. And the smallest number I see looks like 0.06. So once again, I'm going to go ahead and count it off in 0.5s. Let's do that. 0.05, 0.10, 0.15, 0.20, 0.25, and 0.30. Actually, I'm going to make those a little larger apart. I think I can afford to do that. Sometimes it takes a little bit of finagling. It's a wee bit better. Okay. Now let's go ahead and graph these. So we're going to be comparing high school diploma first. I'm going to go ahead and shortcut that with HSD, high school diploma. So the first one in 1990 was 0.247, which is almost 0.25. So it goes almost up to 25. And then you're going to squish the other one right next to it. 2013 we had 0.118, a little higher than 0.10. Alright, let's go ahead and color code these. 1990 was blue. We're going to keep the 1990 values first always, and the 2013s will be second. Doesn't actually matter, but I've set it up that way. And as long as you keep with that pattern, you should be good. The next one is some college, no degree, so some college, no degree. In 1990, it was almost 20. Let's go ahead and make it look like it's almost at 20. Once again, these are all just estimates. And then the other one was a little past 15. Okay. I'll go ahead and continue graphing things. If you want to pause the video and try to graph them by yourself and check back in with me, that might be a good idea. Next is associate's degree. 0.6 or 0.06, a little higher than 0.05. And then 0.098, so almost at 0.10. And finally, bachelor's degree. Oops, bachelor's degree. 0.07, so a little almost at 0.10, not really. Once again, estimating. And then 2013, 0.11. A little higher than 0.10. Okay, I'm going to go ahead and color code these in. We got the 1990s in blue. And the 2013s in green. Okay, so notice how they are sort of clustered together like that in their groupings. That's how you want to do it when you're comparing two different sets of data. If we had three different sets, you would go ahead and cluster in a third one right near it. So what does this visually help us decide? Well, notice in this year, or not this year, but in high school diploma, so in this category, there were actually more people getting a high school diploma in 1990 than there are in 2013. So getting a high school diploma actually dropped. But oddly, getting a bachelor's degree went up, and so did getting an associate's degree. Interesting. So let's look at the question. At what year is the relative frequency of a 1990 result less than a 2013 result? So when is a 1990 less than a 2013? Looks like these 2 years. Not 2 years, sorry. for those two relative frequencies. So, 4 associates degrees and bachelor's degrees. So, sorry, this question should actually say, for what educational attainment? Small typo there, sorry about that. Okay, so let's look at the next problem. We're going to use the same data from example 5 to graph a horizontal bar graph. So very similar idea, but this time the bars are going to go this direction, which means our numbers are going to be down here. So let's go ahead and plop in the numbers we used before. Same idea. Just plopping down the good old numbers. Alright. So let's go ahead and do high school diploma. High school diploma. Let's see, 1990 was almost 25. So about here. Looks like my horizontal lines are not quite as good as my vertical lines. And then 2013, a little higher than 10. So about, let's say, there. Yeah, about there. I'll color these in later. And then some college, no degree. We have almost at 20. And then, after the almost at 20, oh, this graph is not looking quite as pretty. We have a little higher than 15, so about there. And associate's degree. We have 0 points, so a little higher than here for 1990. And then for 2013, we have a little higher than 10, or no, almost 10, a little below 10. And lastly, bachelor's degree. Once again, a little, so almost at 10, a little higher than 0.5. Kind of running out of room. And lastly, 2013 was 0.115. Right here. Not my finest graph, but it'll do. Yeah. Wait. Okay. Alright, let's go ahead and color these in. I'll use different colors this time for fun. Why not? 1990. We'll go ahead and say that will be red, and then 2013 we will do, what should we do? Try to take a guess at what color I'm going to pick. Okay, I'm going to pick yellow. Were you correct? Alright. So, 1990s is in red. Just awkward silence as I color this in. Hopefully your week's been going pretty well, and hopefully these videos are helping you understand the math. That is my goal. Alrighty, here we go, and we have a horizontal graph. Another way to visualize your data. Sometimes maybe it'll be a little better for your image than a regular vertical graph. You never know. Alright, we have a question. And once again, this should be the edit of for what educational attainment is the relative frequency of a 1990 result greater than a 2013. So for what educational attainments are 1990s greater? Well, 1990 is greater here and here, but it's less than here and here. So, 1990 is greater for, or you could say the relative. Let me rewrite this one. The relative frequency, not relative, the relative frequency of 1990 is greater than 2013 for high school diplomas and some college, no degree. Interesting data, huh? Alright, lastly, let's take a look at the third objective, constructing pie charts. Alright, by definition, a pie chart is a circle divided into sectors. Each sector represents a category of the data. The area of each sector is proportional to the relative frequency of the category. Alright, so normally, or sometimes, you're going to be given data where you may only be given the frequency, and to graph it, you'll need to calculate the relative frequency. So let's see, you have a graph, a pie chart using the following relative frequencies. We have an example here of student reactions to homework. Does homework the day it's assigned, does homework right before class. Next day in classes, we had homework, and as I said, it's a totally untrue example, right? Everyone does it on the day homework is assigned, right? Okay, so here we go. The relative frequency is apparently only 5%. How horrifying. And then doing homework right before class is apparently 20%, and doing it the next day in class is, we had homework? Okay, so graphing this out. Splitting this up, we want to make sure each proportion is correctly labeled. So 75, and then the others are, looks like that's a 25, so I'm going to go ahead and split my circle into 4s. If you wanted, or if you had some numbers that weren't quite as easy to graph, what you would do to graph it is you would take the frequency, the relative frequency, and multiply it by 360 degrees to find out the degree that you would be using, and you would have to use a protractor. But pie charts are not really the main focus of this course, so that's why I don't go over this technique right here. Alright, so we put it into 4s, and 75% said next day in class, or they're in class the next day going, we had homework? I'll go ahead and let this be the red, so that's 75%, which is 3/4 of this entire circle, was surprised that there was homework. Let's go ahead and finish filling this in. And we'll label this nicely. 75%. We had homework. I don't know where that week came from. We had homework. Okay. Then we need to figure out how to graph the 5 and the 20. So 20, let's see, how would I split 25 up? If I split this into 5 separate pieces, then I could go ahead and calculate it out. So let's do ahead 5, 10, 15, 20, 25. So let's see. This would be 5, 10, 15, 20. Yeah, okay. So we split that up correctly. So this little chunk here, it would be the 5%. Once again, you can find the correct angle using that formula there. But we don't focus on that in this course. I want to kind of clean up my graph a wee bit there. Okay, so we have the 5%, which, let's see. 5% does day assigned. And we'll go ahead and, what color do you think I'm going to pick? I pick yellow. Why? I do not know. Alrighty. And lastly, the next piece, the leftovers. The rest is 20%. And go ahead and try to pick the color I'm going to use. I'm feeling like green. Let's see, were you correct? Did you pick the right color? Okay. This amount left over, this is the last one. This is the 20%. I'm assuming most of you have seen a pie chart by now. There are memes out there all the time with pie charts. Alright, does homework before class. So 20% does homework right before class. I actually got this problem from a meme. Okay, so that is it for 2.1. Email me if you have any questions or need help with the homework.